What is a cryptocurrency bridge and how does it work? Bridges are protocols that connect two blockchains, allowing them to interact with each other. For example, a bridge allows you to transfer USDC, stablecoins, from the Ethereum blockchain to the Solana blockchain with ease. But what exactly is a bridge and how does it work? Let's zoom in on a type of protocol that is fundamental to cryptocurrencies and decentralized finance, DeFi. What is a bridge between blockchains? Bridges are born out of a need for communication and mobility of assets between blockchains. They are protocols that connect blockchains to each other. With the advent of Layer 1 blockchains, we see the outlines of a multi-chain future for the cryptocurrency industry instead of the idea of a single blockchain that would sit atop and be used by all. This proliferation of Layer 1 blockchains and Layer 2 solutions, along with a growing number of cross-chain decentralized applications, dApps, that make up the Web3 has led to the need for an infrastructure to connect them. Indeed, by default, most blockchains exist in isolated environments with their own rules, governance mechanisms, native assets, and data that are compatible with other blockchains. As a result, there's no way for them to exchange and communicate with each other, which can limit business and innovation due to the lack of connectivity and interoperability with other ecosystems. Bridges thus offer a way to connect these isolated blockchains. They establish a bridge between networks through which smart contracts, data, tokens, and various information can be transferred from one chain to another. Concretely, if we have an ETH or the Ethereum network and we want to use it on the Near network, it is impossible in a native way. It is therefore necessary to use bridges to connect the two networks. There are several types of bridges, since there is only one way for blockchains to communicate with each other, and each of these bridges has its own advantages and drawbacks. How does a bridge work? Bridges allow to open a one-way or two-way communication channel between different blockchains. In order for this to work and for them to be able to trust each other, off-chain actors have the task of verifying the communications. So, based on this key verification method for establishing trust during communications, we can essentially classify bridges into two categories. Centralized bridges rely on a third party to validate transactions and especially to keep bridged assets. Users then have no choice but to trust the intermediary to use and manage their funds. This type of bridge exists mainly on those that are specific to each blockchain: Harmony Bridge, Wrapped Bitcoin Bridge, Avalanche Bridge, etc. Decentralized bridges. These are based on a smart contract or an algorithm that eliminates the need for an intermediary. Thus, users do not need to trust an entity when using this type of bridge. The security of the bridge type is thus linked to that of the underlying network, also called trustless bridges, Solana's Wormhole, Cosmos IBC, Polkadot Snowbridge, etc. There are different types of connection allowed by bridges. L1L1 connects two Layer 1 blockchains together like Ethereum and Solana. L1L2 connects the main chain of a network with a Layer 2 solution like Ethereum with Polygon. L2L2 connects two Layer 2 solutions of the same blockchain with each other like Arbitrum and Optimism for the Ethereum network. We can imagine Layer 1 blockchains as cities with L1L1 bridges playing the roles of highways connecting cities. The other types of bridges, L1L2 and L2L2, act as roads connecting the different points of interest in a city. Bridges transfer assets from one chain to another in several ways. Lock and mint. Assets on the origin blockchain are locked and mint. Assets on the origin blockchain are locked and an equivalent is minted on the destination blockchain. The most obvious example is the Wrapped Bitcoin Bridge, which locks BTC on the Bitcoin blockchain and mints WBTC on Ethereum. It is the most widely used bridge in the industry. Burn and mint. A bridge of this type burns cryptocurrencies on the original blockchain and mints an equivalent on the destination blockchain. Atomic swaps. These bridges exchange cryptocurrencies from the originating blockchain with cryptocurrencies from the destination blockchain. This type of bridge relies on smart contracts that automatically execute these exchanges, which makes it possible to emancipate oneself from the use of a third party, as with the first two transfer methods. Let's take the example of the Wormhole Bridge. To switch from an ETH to its equivalent on the Solana network, Wormhole hole locks the user's ETH and mints the wrapped Ethereum token WETH on Solana. During this process, the user no longer sees the ETH on the Ethereum blockchain, which has been replaced by WETH on the Solana blockchain. Another well-known example is the Lightning Network. Bitcoin's Layer 2 can be used as a bridge since it's possible to create a payment channel that uses different cryptocurrencies. We can send a payment in Bitcoin BTC and the recipient can receive the equivalent in Litecoin LTC through an atomic swap. How is a bridge useful? Bridges allow for cross-chain information and cryptocurrency transfers. In terms of protocol development, decentralized applications, dApps, can take advantage of the strengths of a different blockchain through bridges and thus improve their performance. For the user, it is a matter of having the choice and taking advantage of the benefits of each network. Also, the interoperability offered by bridges allows developers from different ecosystems to collaborate to build new and better performing platforms. Let's look at some real-world use cases to illustrate the importance of bridges in decentralized finance, DeFi. Let's say we have Ether, ETH, on the Ethereum network, but we find the transaction fees a bit higher to make a transfer. By using a bridge connecting Ethereum to a second-layer solution such as Optimistic Rollup or ZK Rollup, it is possible to benefit from lower transaction fees. Another example on the Aave lending protocol. We lend USDC on the Ethereum network, but we find that the interest rate is higher on the Avalanche blockchain, so we can use a bridge to transfer our USDC from the Ethereum network to Avalanche and thus benefit from a better interest rate. Finally, and perhaps most classically, bridges allow users to explore other blockchain ecosystems without having to buy and sell another cryptocurrency. You can transfer your ETH to another Layer 1 blockchain via a bridge to test the latter's native applications while keeping your ETH.